Today we'll be starting chapter 2, which talks about functions and graphs. And 2.1 specifically talks about the basics of functions and what their graphs are going to look like. And this is part 1 of that video. So there's many objectives here, so you can see why I have 2 different parts to this video. I won't read through those, but you can look at them on your own time. So a relation is any set of ordered pairs, and the set of all first components of the ordered pair is called the domain. And then the second component is the range. So if you think of your x, y coordinate, the domain is the first set of numbers, and the range is the y values, which is the second number in the coordinate pair. So an example of finding the domain and range. Here are different coordinate pairs for a set. So the solution is all the x's are the domain and all the y's are the range. So if you think, I'll just label what the x's would be. You notice that list is right here. And you want to put them in the order that they come, because then you'll be able to match up later that 0 went with 9.1. The 10 went with the 6.7, and etc. So just keep it in the order, and then the x's go in the domain and all the y's go in the range. The definition of a function is that each element in the domain has to correspond to only one element in the range. So a easier way to say that is the x value can't occur more than one time in the set, because each x can only have one unique y value that would match with that. And we'll look at some examples here on the next slide. So we want to determine whether this relation is a function. So if I listed my domains and then my ranges, the domains are the x's, so I have the 1, the 3, the 6, and the 8. And the ranges are the other numbers, the 2, the 4, and then the 5 occurs in 2 different areas. So if you look at this, the 1 went with the 2, the 3 went with the 4, the 6 went with the 5, and the 8 went with the 5. So you notice the x's only occur one time. The range is the one that happens where there's 2 5s that occur, but in this case it only matters that the domain, each of those only occurs once. So yes, it is a function. And I'm going to show you another way to check that. I'm going to plot those points. So 1, 2, I go over 1 on the x, up 2 on the y. Here's my x-axis. Here's my y-axis. And then 3, 4, I go over 3 and up 4. 6, 5, go over 6, up 5. And 8, 5, I go over 8, up 5. So if I look at this, there's nowhere that I would draw a vertical line that would hit more than 1 point. So if I drew a vertical line here, it only hits 1 point. If I drew one here, it only hits 1 point. So wherever I try to draw a vertical line, if it only hits one of the points in those coordinates, it is a function. If it does not pass the vertical line test, then it is not a function. Okay, let's try this one, the domain and the range. All my x's. The 5 happens twice, so we have a red flag already. the 2, 4, 6, 8. The 1 went with the 2, the 3 went to the 4, but then the 5 could go with the 6 or the 8. So this is not a function because the 5 occurred 2 times as an x. So let's try the vertical line test here. 1, 2, 3, 4, 5, 6, and 5, 8. So you can see here, this does not pass the vertical line test, because if I drew a vertical line here, it hits more than 1 point. So does not pass vertical line test. So if you held your pencil vertically, it would end up hitting 2 points in one section, so that makes it not a function. Okay, if an equation is solved for the y and more than one value of y can be obtained for a given x, then the equation does not define y as a function of x, or it's not a function. So I'll show you what that means in an example. It says determine whether the equation defines y as a function of x. So what we're going to do is solve this for y and see what kind of answer we get. So to solve this for y, I'm going to move the x squared over by subtracting it. That leaves me with y equals 4 minus x squared. So in this case, you can see there is only one thing that y can equal. It equals 4 minus x squared. So yes, this one is a function. And so for example, if we tried plugging in x equals 1, are we going to get more than one answer or not? So if I try that, if I replace my x with a 1, just to try out something, see if it works, you're only going to get one solution for y, which is y equals 3. If you would end up getting more than one possibility, then it would not be a function. Okay, so here's another example. So if we tried solving this one for y, to get the y by itself, you would first subtract the x squared, which is how we got this line. So we're left with y squared equals 1 minus x squared. Then to undo that squared, we're going to take the square root of both sides, which is how we get this answer. So this is saying y could equal a positive square root of 1 minus x squared, or y could equal a negative square root of 1 minus x squared. So this is not a function, so it's not defined as a function because there are two different values that could work for the y. Okay, let's try one more of those. Determine whether this one would be a function of x. So I'm going to subtract the 2x. That leaves me with y equals 6 minus 2x. So that is just one answer. So it's yes, it is a function. So if I chose a number for x, if I put it in there, I'd only end up getting one answer to work for the y. Okay, then function notation, it looks like this. It has parentheses around the x. You can read it as f of x or f at x. And that represents the value of the function at that number. So in other words, we're going to replace the x with the number in parentheses in the next examples. So this one I have laid out for you. So here's our function we're trying to solve, and we want to know what would it be. Evaluate means solve when the f is -5. So when the f of x is f of -5. So wherever you see an x, we're going to put a -5. So you can see we'll put a -5 wherever we saw the x. So this over here on this side doesn't really matter. It's just saying what is f of -5 going to be. So now -5 squared is +25. -2 times -5 is +10 plus 7. If you add those together, you get 42. Therefore, f of -5 equals 42. Okay, the next one, if f of x equals x squared plus 3x plus 5, evaluate when f is 2. So we don't know what f of 2 is in our formula. So I'm going to put a 2 in here. A 2 in for this x. And then solve it. So f of 2 would be 4 plus 6 plus 5. So f of 2 would be 15. Okay, now we're going to use that same function, but now we're going to replace our x with x plus 3. So what is f of x plus 3? And let me rewrite this so we can see easier what we're going to replace. So wherever you see an x, you're going to put x plus 3. And that's going to be squared plus 3. Replace the x with x plus 3 plus 5. So you have to be careful here. Remember, this is a binomial times itself. So you're going to need a FOIL on this or do double distributive. So that would be x squared plus 3x plus 3x plus 9, or x squared plus 6x plus 9. You could simplify it. So just this part, we found x squared plus 6x plus 9. Then the next part is plus 3x plus 9, and finally plus 5. So let's put together our like terms. I could put my x's together. So I'd have x squared plus 9x. Then I could put my 9, and my 5 together, which is 23. And nothing else can go together, so therefore f of x plus 3 is x squared plus 9x plus 23. Last example here. So this time I'm using the same equation, but I'm going to replace my x with a negative x. So what is f of negative x in this equation? So let's replace any x with a negative x. And then my positive 5 does not get touched. So now negative x squared, that means negative x times negative x, which is positive x squared. Then 3 times negative x is negative 3x plus 5. And there's actually nothing else we can do on that one. So f of negative x is x squared minus 3x plus 5. So that is the end of part 1 of 2.1, and you can watch the next video for part 2.